Good evening, children.
Good evening.
Good evening.
Good evening, ma'am.
Good evening. Good evening, children. So Rajeshwari was the first to text me. She says she's completed all except 6, 12, 9, and 20. Thanks for texting, Rajeshwari. And then Tarun has completed 12 questions. He's attempted 12 questions. Very good. Thanks for responding again, Tarun. Kanishka, you started late and you have completed till the 14th one. Again, thank you for texting, Kanishka. Ananya has deleted the message. Okay.
I attempted 12 questions.
12, is it? Okay, fine.
Many of them I didn't know how to proceed.
Fine, fine. We'll see the answer now. Yeah, we'll see the answers now. All right. Okay, so Sashmin has also responded. She says, oh, writing pre-board exam. Okay, okay, fine. So she was not able to do it all. Shreya Shri has now texted that she's completed answering 12 questions. Okay. So thank you, students, for responding. Sashmin, Rajeshwari, Tarun, Kanishka, Ananya, and Shreya Shri. Very good. Let's now see the answers from behind, children. We'll work from behind. We'll see the answers from behind. So starting with the 20th one. Okay, so express sine A in terms of secant A. Express sine A in terms of secant A. In terms of secant A. So we know that sine square A plus cos square A is 1. So sine square A is equal to 1 minus cos square A. So sine A is equal to square root of 1 minus cos square A. So sine A is equal to square root of 1 minus 1 by secant square A. So sine A is equal to square root of secant square A minus 1 by secant square A. So sine A is equal to square root of secant square A minus 1 divided by secant A. You need to write sine A in terms of secant A. You'll have to express sine A using secant A. So just pick any relation that connects either sine and secant or their reciprocals also. To write, to bring a relationship between sine A and secant A, you can choose any relation or any identity that connects either sine or cosecant with secant or cos. Because even if you have cosecant, you can write it as sine, right? Because they are reciprocal ratios. Again, don't worry, it can be secant or cosecant because you can write one in terms of the other easily. They are reciprocal ratios. So you need to look for a relation or an identity that connects sine A and secant A, or instead of sine A, it could be cosecant A and secant A also, or it can be cosecant A and cos A, anything, any two of these. So I have picked this identity. Sine square A plus cos square A is 1. In this identity, we see sine A, but we don't see secant A, but we see cos A, which is the reciprocal of secant A. So we find these two. Sine square A plus cos square A is 1. Now we have sine in this, sine A. Now we don't see secant A, but we know that cos A can be written as 1 by secant A. So I use this identity. First we write sine square A as 1 minus cos square A. So sine A is equal to square root of 1 minus cos square A. Now change cos to secant. You can change it here also. See, you can change, you can write cos square A as 1 by secant square A here itself. Not that you should do the change at this step. Anywhere. You can change it anywhere. So here cos square A is 1 by secant square A, common denominator. So secant square A minus square root of secant square A minus 1 by secant square A. So sin A is equal to square root of the numerator divided by square root of secant square A is secant A. So sin A in terms of secant A is sin A is equal to square root of secant square A minus 1 by secant A. Was it easy to understand, children? You might have done it correctly. Just in case you haven't understood, children.
Yes, ma'am.
Yes, ma'am.
Okay, because we need to see all the answers. Take a picture. Maybe you can practice it later. But don't forget to work it in case you have not worked this or you have not got it correctly. Please practice. These questions are from the previous year's board papers. So don't ignore. Yeah, next one. You need to write tan A in terms of secant A. Tan A, right? Tan A in terms of secant A. So this we have a direct, meaning there is an identity that connects tan and secant directly. So we know that secant square A minus tan square A is equal to 1. So secant square A is minus 1 is equal to tan square A. You need to write tan in terms of secant. So you have tan on one side and secant on the other side. So tan A is equal to square root of secant square A minus 1. So here we have expressed tan A in terms of secant A. See, it can be secant A, secant square A, secant cubed A. That's fine. There should be secant A. Not that you have to write tan in terms of secant, but it is secant square A. That is fine. We have now expressed tan A in terms of secant A. So we took up this identity, which has both tan A and secant A in it. So tan A in terms of secant A. So have tan on one side. So minus tan square A. Transpose. So you get secant square A minus 1 is equal to tan square A. So tan A is equal to the square root of secant square A minus 1. That's it. We are done. And then write cosecant A in terms of secant A. Right? Cosecant A in terms of secant A. So children, since we've already written sin A in terms of secant A, we can just use this because we know that sine and cosecant are reciprocals. Okay, so since we've already expressed sine in terms of secant, we'll just take up this. So we know that sine A is equal to, you can just use that. I'll tell you, supposing we'll have to do it separately also, I'll tell you how to do it. So sine A is equal to square root of secant square A minus 1 by secant A. We have this here, by secant A. That's what we found here. All right. So what will be cosecant A then? Reciprocal, right? Reciprocal. What is the reciprocal of? See, you'll have to be careful while writing this, children. Listen to me very carefully. Listen to me very carefully. What is the other way of writing sine A? What is the other way of writing sine A? Sine A can be written as 1 by cosecant A. You have not taken the reciprocal. Okay, see, you can do. Okay, let me do this and then tell you the other one. Sine A can also be written as 1 by cosecant A. We have not taken reciprocals. The other way of writing sine A is 1 by cosecant A is equal to square root of secant square A minus 1 by secant A. See, now Don't get confused. Why are you writing the RHS as it is? Don't you have to take the reciprocal? No, because we have not taken reciprocal in the LHS also. Only if you take the reciprocal of the LHS, you'll have to take the reciprocal of the RHS. Here, the LHS, we have written the equivalent. Sin A is also 1 by cosecant A. You have written the equivalent of sin A, not the reciprocal. Sin A can also be written as 1 by cosecant A. They're equal. Sin A is equal to 1 by cosecant A. Is equal to 1 by cosecant A. You've written the equals. If you take reciprocal in the LHS, take reciprocal in the RHS. You have not taken the reciprocal. You've only written the equivalent. So the equivalent of sin A is 1 by cosecant A. So write the RHS as it is. Now you're taking reciprocals on both the sides. The reciprocal of 1 by cosecant A is cosecant A. The reciprocal of 1 by cosecant A is cosecant A. So the reciprocal of the RHS is secant A by square root of secant square A minus 1. So now taking the reciprocals on both the sides. Or what you can do is, or sin A is equal to square root of secant square A minus 1 by secant A. Now take reciprocals on both the sides. Take reciprocals on both the sides. So it will be 1 by sin A. The reciprocal of sin A is 1 by sin A. The reciprocal of sin A is 1 by sin A. So the reciprocal of the RHS is secant A by square root of secant square A minus 1. So here we are taking the reciprocals of the LHS and RHS. Now, what is 1 by sin A also equal to? The equivalent of 1 by sin A is cosecant A. So we've written the equals. 1 by sin A is also cosecant A. So since you've written the LHS as it is, meaning you've written the equivalent, so write the RHS also as it is. You're not taking reciprocals now. So it will be as it is, secant A by square root of secant square A minus 1. Is this understood, children?
Yes, ma'am.
Very nice. Take a screenshot. I repeat, children, these questions have happened in the board exams earlier. So do not neglect or ignore these answers. If you have not worked it or if you have tried it but not got it right, please make sure you practice it. All right. Now, the 19th one, we're done with the 20th. Now the 19th one. You need to find the sum of 4 minus 1 by n plus 7 minus 2 by n plus 10 minus 3 by n, so on up to n terms, up to n terms. All right, you need to find the sum. You can see the connecting sign here, plus. You need to find the sum up to n terms. Okay, so let's open up the brackets, children. 4 minus 1 by n plus 7 minus 2 by n plus 10 minus 3 by n, like this up to n terms. Up to n terms. So this can also be written as 4 plus, so each one will happen n. So it will be 4 plus 7 plus 10 up to n terms. Minus 1 by, okay, yeah, 1 by n minus is common. So it will be plus 2 by n plus 3 by n up to n terms. All right. See, children, in this bracket, we have 4 minus 1 by n. So 1 by n, 2 by, fine. I first open up the brackets. So 4 minus 1 by n plus 7 minus 2 by n plus 10 minus 3 by n, so on up to n terms. Now gather only the numbers in one bracket. That is 4 plus 7 plus 10. Gather only those numbers, 4 plus 7 plus 10 up to n terms. And then minus is common. See here, minus common. So open bracket 1 by n. So minus into 1 by n is 1 by n, minus 1 by n. And then you have minus 2 by n. So minus into plus is minus 2 by n. Minus 3 by n. Minus into plus is minus 3 by n. So on up to n terms. Is it understood so far?
Yes, ma'am.
Okay. So this will be, here you cannot make out the last term. Here you cannot make out the last term up to n terms. So up to n terms, you cannot make out the last term. But here you kind of can plus 2 by n plus 3 by n. So you know the nth term will be n by n. Now don't write up to n terms. You've written the nth term. The numerator is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the nth term will be n. And the denominator is always n, you can see. So n by n. In the first bracket, you cannot make out the nth term. You don't know the nth term in the first bracket. While in the second bracket, up to n terms, the numerator is made up of natural numbers. The first n natural numbers. So the nth natural number will be n because 1, 2, 3, 4, 5, 6. So the nth natural number will be n. So up to n terms, meaning the numerator will be n and the denominator is n because it's always n. Now don't, in the second bracket, now you should not write up to n terms. We've written already to up to n terms. Am I clear, children?
Yes, ma'am.
Okay, now use the formula and find the sum up to n terms in the for the first bracket. So what's the formula? N by 2. So n by 2 of 2a plus n minus 1 into d. Am I right, children? N by 2 of 2a plus n minus 1 into d. Minus, in the second bracket, 1 by n is common. In the second bracket, 1 by n is common. So what do you get? If you take out 1 by n common, you'll get 1. Tell me 1
Plus 2
plus 2
plus 3. N.
Very good. Yes. So 1 by n is common. Since 1 by n is common, bring out 1 by n. And this is what you will have. 1 plus 2 plus 3 up to n. Now simplify this. That's all. What is this? N by 2 of 8 plus 3n minus 3. This is one thing. OK, this is the first portion. Minus 1 by n. Here you will again get what? The sum up to n terms, natural numbers up to n terms, n by 2. So it will be n by 2 only. N by 2 is n by 2 only here. Of 2a, n by 2 of 2a. 2a meaning 2 into 1, 2. Correct, children?
Yes, ma'am.
Let me put this n by 2 outside because. OK, so see, I'll just write it like this. N by 2. See this 1 by n as it is into n by 2 of 2a plus n minus 1 into d is 1. So this is just a second. Yeah, sure. So this is going to be n by 2 into 8 minus 3 is 5, 5 plus 3n, 5 plus 3n. Minus n gets cancelled here. So you have 1 by 2, children, 1 by 2. And then in the bracket, 2 plus n minus 1. Am I right so far, children?
Yes, ma'am.
Yeah. Then, yeah, children. So the next step will be what? 5n plus 3n square by 2, correct? 5n plus 3n square by 2. So that is equal to 5n plus 3n square by 2 minus minus, what is this? What do you get? 2 minus 1 is 1. 2 minus 1, 1. 1 plus n or n plus 1 by 2. Correct? N plus 1 by 2.
Yes, ma'am.
Yeah. N plus 1 by 2. N plus 1 by 2. So now 2 is the common denominator. So 5n plus 3n square minus n minus 1 is equal to 3n square plus 4n minus 1 by 2. So this is the required sum. This is the required sum. Wasn't that easy, children? Easy to understand?
Yes, ma'am.
Yes, ma'am.
It's okay if you were not able to try it, that's fine. But now is it easy to understand?
Yes, ma'am.
Yes, ma'am.
Yeah, kindly practice, children. Please practice. Board questions. You want a screenshot? Please take a screenshot.
Ma'am, can you show the next slide?
Ah, yeah, sure, sure.
Thank you.
Yeah. All right, children. The next one, that will be 18th. 18 we have done in the class, but I'll do it now. A minus b into x squared plus b minus c into x. Okay, the roots are given to be equal. The roots are given to be equal. That means the discriminant is equal to 0. So d is equal to 0. That means b square minus 4ac is equal to 0. I'll do it fast because all of you know this. So b square, so b minus c the whole square, b square minus 4 into a into c is equal to 0. Please tell me if I'm going wrong anywhere. See, minus 4 into AC minus A square minus BC plus AB is equal to 0. So B square plus C square minus 2BC minus 4AC plus 4A square plus 4BC minus 4AB is equal to 0. So we'll arrange it now. So 4A square plus B square plus C square. Then AB minus 4AB. Then BC, we have 2 BC terms. So plus 4 BC minus 2 BC will be plus 2 BC. So A square plus B square plus C square, AB and BC, we have 2 terms, we simplify them, and then minus 4AC is equal to 0. That is, there are 3 perfect squares here, children. 4a square plus b square plus c square. So this should remind you of the identity x square plus y square plus z square plus 2xy plus 2yz plus 2xz is equal to x plus y plus z the whole square. 9th standard. Okay, the identity you need to recall from 9th standard is this one. X square plus y square plus z square plus 2xy plus 2yz plus 2xz is equal to x plus y plus z the whole square. This is the identity. So here in this identity, you can see in the left hand side, you have 3 perfect squares. And then you have 3 other terms whose numerical coefficients are 2. So we somehow have a feeling that, you know, this equation might go with this identity. So let's try that. So for that, we arrange the perfect squares in the beginning. So 4a square plus b square plus c square. And then the ab term, bc term, and the ac term. Now let's try to show that it's really of the form x square. So it will be, okay, let me use empty brackets first. See, use empty brackets. So you're trying to show that it's of the form x square plus y square plus z square plus 2 into x into y plus 2 into y into z plus 2 into x into z is equal to 0. You're trying to show that these 6 terms go with this identity. These 6 terms go with this, go with the left-hand side of this identity. So x squared, 2a, the whole square, y squared, z squared, 2 into a into b. So 2, now see there are 2 terms with a minus sign. So minus 4ab, and minus 4ac you have. So where a is common, so that a term fix a minus sign. Or you can also fix a minus sign to the b and c terms. You can do 2 things. You can either fix since these terms minus 4ab, this 4ab and 4ac both are negative, and the algebraic factor common, is a. So to that a term, fix a minus sign. Or if you don't want to put it there, you should put it to both b and c. Only to the common one, or to the other 2 non-common ones, b and c. So you can do anything. You can fix. So I normally fix it to the common one. You can also fix it to both b and c. Both will work. Both will work. You can fix it to both b and c, or fix it only to the common algebraic factor, which is a. So I fix it to the a term, minus to this one. Minus 4ab, minus 4ac. Negative terms. Algebraic factor common is a. Fix a minus sign to the a term, or don't fix it to a, fix it to both b and c inside the bracket. Okay, so now it will be 2 into minus 2a into b, then b into c, then minus 2a into c. Now check minus 4ab plus 2bc minus 4ac is equal to 0. Perfect. So this is nothing but x plus y plus z the whole square. X plus y plus z the whole square is equal to 0. So minus 2a plus b plus c is equal to 0. Whole square is equal to 0. So square root of 0, 0. So we have b plus c is equal to 2a. B plus c is equal to 2a, or 2a is equal to b plus c, hence proved. So see, 9th standard identity comes to your help here. We have done this in the class. We have worked a set of standard questions. Done, children?
Yes,
Yes, ma'am.
Okay. Next one. Yeah. So now 29, 17. Okay. The population of a village is 5,000. Okay. If in a year, the number of males were to increase by 5% and that of females by 3% annually. So every year, the male population increases by 5% and the female population increases by 3%. The population would grow to 5,202 at the end of the year. Okay. Find the number of males and females in the village. Okay, so this goes back to percentages of 8th standard. Percentages of 8th, 7th and 8th standard. All right, so since we'll have to find the number of males and females in the village, let the number of males be X, number of females be Y. Now the present population is 5,000, so which means X plus Y is equal to 5,000. X plus Y is equal to 5,000, correct? Okay, then the new population is 5,202. And how does that happen? The number of males increase by 5%. So increase X. So new male population is equal to the present population of X plus 5% of X, because it increases by 5%. So plus 5% of X. So that will be X plus 5% means 5 by 100 of X. So like this. So when you take the LCM, you will get 100X plus 5X. 100X plus 5X, which is 105X by 100. This is the new male population. New female population is equal to, it increases by 3%. So Y plus 3% of Y. 3% of Y. So Y plus 3% means 3 by 100 of Y. So I can just put a Y here. On taking the LCM, you get 100Y plus 3Y, 103Y by 100. And the sum of these two. Okay, so it's clear from the given conditions that this plus this, the new male population plus the new female population is equal to the total population of 5,202. Now this you can solve, children, because we need to see the other answers also. So this you can solve. Solve and find the values of X and Y. I don't have the answers, children, because I can't complete because I don't have the answers. So maybe I can work and give you the answers later, but you should be able to get it. We have constructed the equations. Has anyone solved this and got the answer?
Yes, ma'am. I got 2,600 males and 2,400 females.
Okay. 3,600 and 2,400.
2,600 and 2,400.
Okay. 2,000. Okay. Very good. All right. So others also can check if you're getting males 2,600, females 2,400. Okay, we could check it now. So the total is 5,000. Males, it increases by 5%. So 10% is 260. 10% is 260. So 5% will be 130. So that means it will become 132,730. Then this one increases by 3%. 10% is 240. 1% is 24. So 3% will be 72. So this will become 2,000. How much is it? 72. 472. So 201 carried over, 12, 1 carried over, 5. Yeah, that's right. Yes, this is right. You must get number of males is equal to 2,600 and number of females is equal to 2,400. You're right, Ananya. Very good. Understood the equations, children?
Yes, ma'am.
Any questions, children? Please ask. Okay. Next one, 18. No, sorry, 16. 16. When 6 boys were admitted and 6 girls left. So that means the number of boys and girls are now different, but the total strength remains the same. Because 6 boys are admitted and 6 girls leave. So the total strength of the class remains the same. But there is an increase in the number of boys and decrease in the number of girls. but the total strength remains the same. Fine. When 6 boys were admitted and 6 girls left, the percentage of boys increased from 60% to 75%. Find the original number of boys and girls in the class. Okay. So this also, it's easy to construct the two equations. So first, okay. All right. So let the number of boys be X. Let the number of girls be Y. So 60%, 75% both represents the percentage of boys. So the original percentage of boys is equal to 60%. So how do you find this? Percentage of boys will be number of boys by total strength of the class. Total strength of the class into 100, and that is equal to 60. That is equal to 60. See, now you'll have a doubt if you should write 60 or 60 by 100. You should not write 60 by 100. If at all you have that doubt, I'll tell you what else you can do. 60%, that percentage into 100 is here. See, 60% means what? 60 by 100. So that means the ratio is 3 by 5. The ratio is 3 by 5. And how will you find the ratio? Number of boys by the total strength. See here, supposing you have the doubt, children, I'll tell you can do it like this. Okay, so is equal to 60. Now you can understand this better, I think. See here, number of boys. Or let me just work this here, children. Number of boys. See this one. See this one. Number of boys by the total strength of the class is equal to 60 by 100, which is 3 by 5. That makes sense, no? See, boys by the class. The ratio of boys to class is 3 by 5. Does it make sense or no? Boys to class. The ratio of the boys to the class is 3 by 5. Boys by the total strength is equal to 60 by 100, which is 3 by 5. For 60%, you should not use 100 again. 60% should not be written as 60 by 100 because that 100 is only here in the formula. That by 100 only is here as into 100 in the formula. It's only equal to 60. Okay. So now number of boys X by the total strength X plus Y is equal to 60 by 100. So X by X plus Y is equal to 3 by 5. Cross multiply and you will get the first equation. 3x plus 3y is equal to 5x. So you will get 5x minus 3x is 2x. 2x minus 3y is equal to 0 is the first equation. Now the second one, the new percentage of boys. New percentage of boys is equal to 75%. So that means the new strength of boys by the new strength of the class, new strength of the boys by new strength of the class. Because how do you find the percentage of boys? Boys by class into 100. Boys by class into 100. So the new strength of the boys by the new strength of the class into 100 will be equal to the percentage, 75. This is how you find the percentage. How do you find the percentage of boys? Number of boys by the total number of students in the class into 100 will give you the percentage. So the new strength of the boys, 6 boys are admitted. So X plus 6 by the strength of the class, that remains the same. But if you want to show that the number of boys X plus 6 plus number of girls Y minus 6. So this is the strength of the class. This is the total strength of the class X plus 6. number of boys, y minus 6, number of girls. So both put together, the new strength of the class into 100 is equal to 75, or you can write 75 by 100 is equal to 75 by 100. 75 by 100. So x plus 6 by x plus y, because plus 6 minus 6 cancels, is equal to 3 by 4. Cross multiply, 4x plus 24 is equal to 3x plus 3y. So you get x minus 3y is equal to minus 24. So you have the two equations. Solve to find the values of x and y. Anyone has the values of x and y? Number of boys and number of girls?
X is equal to 24 and Y is equal to 16, ma'am.
X is 24, X is 24, Y is 16. Okay, so let's check. So percentage of boys, or the fraction of boys is 3 by 5. So 24 by 40, correct. 8 3s are 8 5s are 3 by 5. Now the new strength is 30 boys, because 6 or 30 boys, but the total strength remains the same, 40. And the ratio is 3 by 4. The new ratio is 3 by 4, correct. 24 and 16. 24 and 16. On solving, you'll get 24 and 16. All right. Next one. Children, see, this is the formula to find the percentage. Percentage is, supposing you'll have to find the increase percentage. Increase percentage will be increase in value, whatever is the increase, by the original value into 100. Decrease percentage will be whatever is the value of decrease by the original value. Decrease by original value into 100. See, how do you find the profit percentage? Profit by the original price, CP, into 100. Loss percentage, loss by CP into 100. Whenever you find a percentage, you multiply by 100. When you multiply by 100, you're finding the percentage. So percentage of boys will be number of boys by the total strength of the class into 100. Percentage of girls will be number of girls by the total strength of the class into 100. Okay, now the 15th one. I'll do 15 and then the 11th one. Somebody said 12 also you did not get, right? Let me check. Rajeshwari says 12 you did not get. 6, 12, 19, 20. 19, 20, 6 and 12. 6 and 12. Okay. Rajeshwari, 6, similar question we have done in the class. I think you missed the class. Did you go through the recording?
One recording to go, ma'am. Other two have watched, ma'am.
Okay, we'll do it now, but a question similar to 6 was done in the class.
Okay, ma'am.
No problem. We'll do it now. So children, we'll wind up today's session with. Okay, let me do the 15th one. We can't do the whole paper. I'll just pick the important meaning, the ones which really need to be discussed. The simpler ones I'll leave it to you. We'll see it in tomorrow's class. The 15th one now. Class, use the emoji. Raise your hand. Tarun, Ananya, Pranav Rajan, Rajeshwari, Kanishka, Shreya Shri, Subbalakshmi. Are you there, Priyanka? Okay. Very good. All right, children. So the 15th one, in an election contested between A and B. Okay, so two candidates stand for the election. A obtained votes equal to twice the number of persons on the electoral roll. 1 minute, what have I written? Twice the number of persons on the electoral roll who did not cast their votes. Okay, who did not cast their votes. And this number was later equal to twice his majority over B. Okay, if there were 18 persons on the electoral roll, how many voted for B? Okay. I just need to read the question again. I'll just read it to myself. Okay. All right. So we'll just assume that A receives X votes. Okay, see, children, before that, I need to tell you this. See, supposing 100 out of a very small population in a village, say 100, see, the population of the village may be 250. But of 250, the number of people eligible to vote, that is people who are 18 and above, maybe only 100. So only the population of the village may be 250, but only 100 are eligible to vote because only 100 are 18 years or above 18 years of age. Now of this 100, all of them may not vote. So this is the, in the electoral roll, so many people are there. 100 people should actually cast their votes. But you know, in our country, mostly in villages, people use their right to cast their votes. In metro cities, people, okay, I think we shouldn't go there. Fine. No, let me stop there. Sorry. So 250 is the population of the village. But of this population of 250 people, only 100 are, 18 years or above 18 years of age. So only they are eligible to vote. So this is the number of people in the electoral roll. But of the 100 people who are supposed to cast their votes, only 80 have casted their votes. 20 have not cast their votes. Either they are lazy or, they forgot or whatever. 20 did not cast their votes or they are not interested because they don't understand the importance of using their vote. For some reason, 20 of them did not cast their votes. So 100 people are there in the roll. 100 people were supposed to cast their votes. If 100% of the people have voted, that means 100 people should have voted. But no, only 80 cast their votes. 20 did not cast their votes. So when 100 people are there in the electoral roll, doesn't mean that all the 100 have casted their votes. So in this case, in our example, 80 have cast, 20 have not cast. So people who have cast their votes plus the people who have not cast their votes together is equal to the number of people in the electoral roll. People who have cast their votes plus the people who have not cast their votes. This is the total number of people in the electoral roll. Okay. So this is, so let the number of votes received. Okay, so in this example, 80 and 20, if there are two contestants A and B, maybe A has got 60 votes and B has got 20 votes. 60 plus 20 is 80 because only 80 votes are casted, 20 votes not cast. So of this 80 votes casted, A has got 60 votes, B has got 20 votes. So 60 plus 20 is 80. It will not be 100. The number of votes received by A plus the number of votes received by B will be equal to the number of votes casted. Number of votes casted plus the number of votes not used, not casted, will be the total number of people in the list. Is this part clear, children?
Yes, ma'am.
Yeah. So number of votes received by A plus the number of votes received by B is equal to 80, which is not the total number of people eligible to vote. Only 80 have cast their votes, 20 have not casted. 80 plus 20 is 100. So let the number of votes received by A be X, and let the number of votes received by B be Y. Okay. Now what is X plus Y? X plus Y is not the total number of people in the electoral roll, because there are people who have not cast their votes also. Okay, so total number of votes casted, total number of votes casted is equal to X plus Y, is equal to X plus Y. Now, if there were 18,000 persons on the electoral roll, okay, fine, there are 18,000, but only X plus Y have casted. So 18,000 minus X plus Y have not cast their votes. So number of votes not casted is equal to 18,000 minus X plus Y. 18,000 minus X minus Y. There are two contestants. A receives X votes, B receives Y votes. So total number of votes casted, X plus Y. But how many people are there in the list? 18,000. Have all the 18,000 people cast their votes? No. Some of them have not used their votes, have not casted their votes. But how many have casted? X plus Y. Because A has got X votes, B has got the remaining Y votes. So X plus Y is the number of votes casted. So the number of votes not casted is equal to 18,000, the total number of people in the electoral roll, minus casted. Am I right so far, children? So these are the basic assumptions we need to do before you construct the equation. Before you construct the equation, you need to write all this. How many A got, how many B got. So then what is the total number of votes casted? Then how many not casted? You must have these four ready. Now read the question. Is this understood, children? Am I right so far?
Yes, ma'am.
Yes, ma'am.
All right. Now let's go back to the question. A obtained votes equal to twice. So A obtained votes. So what is how much A got? X. X is equal to obtained votes equal to twice the number of persons on the electoral roll who did not cast their votes. Okay. So see, twice of this one. Correct. That's what is given straight away there. And this number was later equal to twice its majority over B. Oh, that means A has won. A has won. Okay. So now supposing in our earlier example, 100, I said, and 80 and 20, I said, and I said A got 60 and B got 20. So what's so A has won by a majority of 40 votes. A has won by a majority of 40 votes because 60 minus 20 is 40. So what is A's majority over B? 60 minus 20. The difference in votes is the majority. Majority is the difference in votes. A has won by a majority of 40 votes. In our example, A has won by a majority of 40 votes. Meaning A has won the elections A has won the elections. A has won the elections by a majority of 40 votes, meaning the difference between the votes received by A and B is 40. Okay, so A obtained votes equal to twice the number of, see here, A is X. Received votes, meaning A equal to twice the number of, twice the number of persons on the electoral roll who did not cast their votes. So many did not cast their votes. Twice that number. So this will be X is equal to 36,000 minus 2X minus 2Y. Let's just make this equation. So you will get, when this goes outside, so it will be 3X. I hope I'm right. Plus 2Y is equal to 36,000. This is one equation. And this number was later equal to, which number was later equal to this, this one? 180 minus, yeah. And this number was later equal to twice as majority over B. Now, what should I write? What is A's majority over B? X minus Y. A's majority over B is X minus Y. The difference in votes, that's all. Majority is the difference in votes. So A's majority over B is X minus Y. Twice as majority over B is 2 into X minus Y, correct? Yeah, please respond, children. Right or no?
Yes, ma'am.
Yeah, now tell me the equation. Let me see how much you understood. Tell me the equation.
What does this number mean? What do they refer to by the word this number?
This number is that twice the number of people who did not cast their votes.
Number of votes received by A, ma'am.
Not twice, sorry, not twice. This number is that 180, 18,000 minus X minus Y.
The number of people who didn't cast their votes.
Number of people who did not cast their votes, correct.
Ma'am, so they're saying the number of people who didn't cast their votes is equal to twice the majority A had over B.
Perfect, correct.
Ma'am, so 18,000 minus X minus Y will be equal to twice of X minus Y.
Perfect, that's it. So as Ananya rightly asked, see, I'll just read that for you again. Twice the number of persons on the electoral roll who did not cast their votes, and this number who did not cast their votes, and this number meaning number of people who did not cast their votes. Let me write that. No, I think simply reading 1 minute. Let me just write only that part. No, in an election contested between A and B, A obtained votes equal to twice the number of persons on the electoral roll who did not cast their votes, and this number, meaning who did not cast their votes, this number and this number was later found, not found, later was later equal to twice his majority over B. Okay, so clearly A has won the elections. Okay, so see here, twice the number of persons on the electoral roll who did not cast their votes, and this number represents who did not cast their votes, was later equal to twice its majority over B. A's majority over B is X minus Y. A's votes minus B's votes. A's votes received by A minus votes received by B. The difference is the majority over B. Twice meaning 2 into is equal to who did not cast their votes. 18,000 minus X minus Y. Am I clear, children? So this is the second equation. This is the first equation. The second equation is this one. 2 into X minus Y. Majority over B is X minus Y. Twice that is 2 into X minus Y. Is equal to who did not vote. So 2X minus 2Y is equal to minus X minus Y. So 3X plus Y. So minus Y is equal to 18,000 is the second equation. Yes, children, take a screenshot. All right, now 14, we'll see tomorrow. 13, we have done it in the class, so I'll share the picture of that one. I think I have that ready with me. I'll just share the working. We have also worked this in the class. We'll see 13 tomorrow. I'll share the answer with you. Then 12, okay. We'll do 12 and 11 now and wind up the session for today. We'll continue the discussion tomorrow. I'll do 12 and 11 now. Those who want to stay can stay. If you feel it's getting late for you, please use the recording later. So if at least one of them are in the meeting, I'll continue. If there's nobody, then I have to end the meeting. Okay, so now we'll do, as I said, 12 and 11, and we'll wind up the session for today. So the 12th one, solve for X. So you can see the equation. 2X by X minus 5 the whole square plus. Okay. So let 2X by X minus 5 be A. So what will it be? A square plus 5A minus 24 is equal to 0, right? So children, you can see that expression 2X by X minus 5 two times. 2X by X minus 5, 2X by X minus 5. So we'll replace that with A. So when you reconstruct the equation using A, you get A square plus 5A minus 24 is equal to 0. Yes or no? Sometimes, see, it can be 2X by X minus 5 in one place, and in the other place, it can be X minus 5 by 2X. In that case, you should say, let this be A. So this will be 1 by A. Supposing, sometimes it's like that. Sometimes they'll give you X plus 1 by X, and then in a other place, it will be X. 1 plus X by X, like this. So if you call this one as A, this will be 1 by A. But here it is 2X plus X, 2X by X minus 5 in both the places. So A square plus 5A minus 24 is equal to 0. Split the middle term. split the middle term. So a square plus 8a minus 3a minus 24 is equal to 0. So a into a plus 8 minus 3 into a minus into plus is minus 8 is equal to 0. A plus 8 into a minus 3 is equal to 0. So a is equal to minus 8 or a is equal to 3. So if a is minus 8, that means 2x by x minus 5 is equal to minus 8 because a is 2x by x minus 5. Cross multiply 2x is equal to minus 8x plus 40. So 10x is equal to 40, x is equal to 4. Or 2x by x minus 5 is equal to 3. Cross multiply 2x is equal to 3x minus 15 minus x is equal to minus 15, x is equal to 15. So x can be 4 or 15. Understood?
Same answer.
Very good. Okay, so Ananya's got this answer. Very good. All of you understood?
Yes, ma'am.
Yes, ma'am.
Very good. All right, children. So we'll just do the 11th one and say good night for today. Find the middle term of the sequence formed by all 3-digit numbers that leave remainder 5 when divided by 7. So when divided by 7. So let's write the tables of 7. 13, I'll start from 7. 13 sevens are 91. 13 8 times 98. 13 9 yeah. What am I writing? I'm writing the tables of 13. Sorry. Need to write the tables of 7. 13 times. Oh my God. Sorry. See, whenever it gets late and all that, I just lose my cool. From where should I start? 7 into 12 is 84. 13. Yeah, okay. 91. Then 7 tables. 14 times 98. 15. 105. I'm right, no children? 6 7 42. 4. All right. So these are the multiples of 7 children. So let me start from. You can start from 91. Just take a few numbers before the 3-digit number. Okay. So let's just do this. Okay. 91, 98, 105, 112. Goes on like this. What's the last number? 7 ones are 7. 2 9 comes down. 7 4s are 28. 1 9 comes down. 7 2s are 14. 5 is a remainder. 5 is a remainder. So 999 minus 5. 994 is the last number. 994. These are the multiples of 7. See, when divided by 7, right? When divided by 7. So find the multiples of 7. And it's about the 3-digit multiples of 7. It's about the 3-digit multiples of 7. So we've written the 3-digit multiples of 7, and along with that, we've taken 2 numbers prior to the first number, 105. You can also take a number after this. See, just take a number after this. So it will be plus 7. So 1001 plus 7, 1008. Okay. So now leaves remainder 5. So keep adding 5. Add the remainder 5. Add remainder 5. So it will be 96 plus 5, 103 plus 5, 110 plus 5. So plus 5, 999 plus 5. This one plus 5. This one. So now you need to ignore this number. You need to ignore this and this. Because you want the collection of only 3-digit numbers that leave remainder 5 when divided by 7. So how do you find the sequence? When divided by 7, So first write the multiples of 7, the relevant multiples of 7. Because it is when divided by 7. So first write out the relevant multiples of 7. What do we mean by relevant? 3-digit multiples of 7. But don't be very strict with that. Take a few numbers before and after. After is not required. But now I can't explain why not after. So kind of you need to get that yourself. So if at all, so since I'm not able to answer that question, I'm saying take 2 numbers before and after. Divided by 7. So you need to take relevant multiples of 7. Relevant meaning 3-digit multiples of 7. But we're not going to be very strict there. We're going to take 2 numbers before the 3-digit number and after the 3-digit number. So 105 is the first 3-digit multiple of 7. 994 is the last 3-digit multiple of 7. We take 2 numbers, 2 multiples after 994. We take 2 multiples before 105. And now add the remainder to every number in the sequence. Add the remainder 5 to every number in the sequence. 91 plus 5, 98 plus 5, 105 plus 5, 112 plus 5, and continue that. Now strike out the numbers which are not relevant. The numbers that are not relevant in the sequence are those apart from the 3-digit numbers. This is the sequence. You need to form the sequence of all 3-digit numbers which leave a remainder 5 when divided by 7. Divided by 7. So write the multiples of 7. Remainder 5. So add 5 to the multiples of 7. And take the relevant multiples. Take only the 3-digit multiples. Now write. Now the required sequence. The required sequence, or you can just write the sequence. The sequence of all 3-digit numbers that leave remainder 5 when divided by 7 is 103, 110, 117, so on up to 999. Now you need to find the sum of all the numbers. Oh, first we need to find the middle term of the sequence. First we need to find the middle term of the sequence. And then we need to find the sum of all the numbers on both the sides of the middle term. Okay. So the middle term will be, for that you need to find the number of terms in the sequence. So an is equal to 999. A plus n minus 1 into d is equal to 999. 103 plus n minus 1 into 7 is equal to 999. N minus 1 into 7 is equal to 999 minus 103. So 896. N minus 1 is equal to 896 divided by 7. N minus 1 is equal to 7 1s are 7, 7 2s are 14, 5 7 8s are 56. N is equal to 129. N is 129. So there are 129 numbers in the sequence. And which is the middlemost one? Middlemost term is equal to 129 plus 1 by 2. 129 plus 1 by 2. This term, that is 130 by 2th term. That is the 65th term. The 65th term is the middlemost term. The middlemost term is 129. It's odd. So add 1 and make it even. 121 is odd. Add 1 and make it even and then divide by 2. 130 by 2. 65th term is the middlemost term. So you need to find what you have to find. You'll have to find the middlemost term That's the 65th term. Find A65. So you need to find these three things, children. We'll do this tomorrow. You need to find the 65th term. You need to find the 65th term. And then you need to find the sum of the first 64 terms, because A1, A2, like this. 1 minute, I don't have space. Here. A1, A2. I'll not put the comma, children. I'll write it without the comma. A1, A2, A3, A4, like this it goes on. A64, A65, A66 goes on till A129. That's all. Only 130 terms are not there. Only 129 terms are there. So this is the middlemost term. This is the middlemost term. You need to find this sum and this sum. You need to find the sum of all the terms before the 65th term and the sum of all the terms after the 65th term. That's what is given here. Also find the sum of all numbers on both the sides of the middle terms separately. The middle term is the 65th term. On both the sides, A1 to A64, find the sum. And on the other side, A66 to A129, find the sum. So first you need to find the middlemost term, that is A65. Then you need to find S64, the sum of the first 64 terms. The sum of the first 64 terms. And then you need to find the sum of all the terms from the 66th to the 129th. So for this you should find, for the last one you should find the sum of all the 129 terms minus the sum of the first 65 terms. The sum of all the 129 terms minus the sum of the first 65 terms will give you the sum of the terms from the 66th to the 129th. This is one way. There is another way. We'll see it in tomorrow's class, children. It's getting late for you. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Yeah. Fine, children. So if possible, please complete this answer by tomorrow's class. If you have not worked this, please work this. Have this answer ready by tomorrow's class. Tomorrow's class also, children, I'll let you know. It will mostly be online. Tomorrow's class also will mostly be online. I'll let you know the time by tomorrow morning. Anyways, all of you, will be at home because you must be studying for your mock exams at school, or your boards are, around the corner. So I'm sure you'll all be at home. I'll let you know the time tomorrow. By tomorrow morning, it will mostly be online. All right, children, let me show you the 2 slides. Take a screenshot. All right, children. Thank you so much for your patience. Thank you, children. That's it for today's class. Good night. You may leave the call.
Thank you, ma'am.
Thank you.
Thank you, children. Thank you. Good night.
Thank you, ma'am.
Thank you, children. Good night. Thank you.